Good afternoon, Gabriele.
Good afternoon, Angelo.
And hello, everyone. Welcome to our webinar. So we are going to talk about the Zetta platform today.
Yes, exactly.
And we are going to make it quite practical.
Exactly.
So what I suggest is that we just set real quick the context by going through a couple of slides, and then we'll
start rolling.
Exactly. We'll dig in the Zetta Scale platform. Okay, so let me just share my screen. Okay, so that looks just about right. And I would say, let's go.
Let's start, yes.
Okay, so today we're going to talk about infrastructure and managing infrastructure.
That's going through.
Yes, actually, I need to change one settings here. Whoops, operator error. Oh, this is the magic of history. Now it's completely out of my history. That is great. So let me stop just 1 moment sharing the screen.
But this showed that everything is live.
Yeah, absolutely. Absolutely. And that was an unfortunate key combination. Okay, we are back online and I'll be sharing my screen in just about 1 moment. Okay, so that should be good. So let's see. To go back, sharing the screen. That looks just about right. And so let's try this one again.
Without closing the
the keynote. Okay, so as we were just about to say, today we're going to discuss how to manage infrastructure that allow you to connect, compute, and store from the device up to the data center, or vice versa, from the data center down to the device.
And also up to your data center,
which is very important. And in general, why is this increasingly important? Well, because if you look at how connectivity is growing, I mean, we're going toward a massive challenge. There are statistics that say that 80% of vehicles in 2030 will be connected.
Wow, it's a lot.
It is a lot. And it's interesting because, we have been discussing decentralization for
long
decades,
time.
Right?
Exactly.
And before it was, yeah, sure, one day. But today, it's really becoming a challenge. And for sure, we won't be able to support that number of connected devices in a centralized architecture, like the architecture based
that
on
we have nowadays.
Exactly. For instance, based on MQTT for cloud-to-device communication. And so this is a challenge for the automotive industry. We have covered how actually we can improve communication on the vehicles, but perhaps what we do today will resonate more for those of you that are looking into V2X. But again, this is also a problem in robotics, because the bulk majority of the growth in robotics is in mobile robotics. And mobile robotics, AMR, like in this picture, or AGV, might be connected within a factory, right? And so in that case, I would be very much interested in optimizing and containing as much as possible the communication within the factory. So my the bulk of my infrastructure is the factory. Why should my data get out? Perhaps I don't even want that. Or in some other application, I might need to teleoperate. We have worked on a scenario where there is a natural disaster or an earthquake, and you need literally either to give target to a robot that is by yourself because there is no internet now, or on the other side, an issue in a nuclear central. In that case, you're teleoperating.
Yeah, you also don't want to be there.
Right, but still, in spite of where I am, right, I want to be able to interact with my robot in the most direct manner.
Exactly.
And once again, not every technology is able to do that. And once more, how can an infrastructure support this kind of scenarios? So the trend is definitely that more and more systems are required to span from the cloud down to the microcontroller. Again, a car is an example. You have more than 200 microprocessors in a car, some microcontroller, some that are more server-like, but this is now leaking out into the edge, and there are already some elements on the data center. The same applies to robotics, but I would argue the same is true for medicine.
Yeah, I mean.
And it will all increase, right? I had a family friend that is being implanted now a small a sensor to continuously monitor the heart, skin.
Okay.
Right? I mean, today these people have to go regularly to the hospital.
Yeah, to get it. Yeah, to download the data.
Right. Wouldn't it be great?
Yeah, to not go to the hospital.
Exactly. And to have it on your,
Exactly. Yeah,
so those are the sort of innovation that can change people's life.
Yeah,
it would be quite interesting, to work on. And we are starting to see application of our protocol in medical, which is quite exciting. Yes. And again, before Zeno came around, doing this kind of application was leading this kind of monstrous digital Frankenstein, where you had to stitch technology together to just try to get some kind of sense out of this heterogeneous collection of networks, devices, and so on and so forth. So as we've discussed in many of our previous seminar and webinar, Zeno is our answer to solve these problems, to provide you with a core technology that allow you to communicate across any network, from the smallest microcontroller up to the data center, to perform. And a technology that completely removes all topological constraints, as we will see in a moment. I won't spend too much time because we have spoken so much about Zeno, right? So as of today, you find Zeno used in automotive. So for instance, U protocol from GM, right, is entirely based on Zeno. Yeah. If we look at the ROS2 ecosystem, ROS2 is massively moving on Zeno. Alphabet Intrinsic has been pushing this, and they've presented and written quite a few interesting things about Zeno. So it's sufficient to do a Google search to find some of that. And we have had an increasing number of unicorns adopting our technology in very disparate domains,
market,
right?
Yes,
from aerial drones, big things, right?
Big things that flies,
to very small things that moves, and anything in between.
So that shows like the cloud microcontroller thing.
Exactly,
in reality.
And it's just about anything you can imagine. We have traction in industrial, but to be fair, one of our earliest commercial deployment was in industrial, right?
Yeah, indeed.
Soft PLCs and industrial management. Exactly. Medical, defense aerospace, well, not to mention few blockchains already powered by Zeno. And these are the kind of application where you find our protocol, right? From autonomous train to lots of robotics, some R&D, autonomous cars. We do have actually a full-blown automotive stack. You've worked on that in the past, running on Zeno. You're seeing that running in Carla. So anybody interested in playing around with autonomous driving, we actually have a native stack. And, again, lots of studies identifying Zeno as the ideal protocol for robotics, the protocol to standardize for automotive. This is a recommendation from ITUT, and so on and so forth. And why so? Well, there are multiple reasons that we just mentioned. The fact of unifying compute, storage, and communication end-to-end, and the complete absence of topological constraint. Okay, so in here, just to put it into perspective, you have an example topology that you could implement with Zeno, and a topology that MQTT forces on you, which is the broker-centric architecture, where the question is, where do I deploy the broker?
How big is the broker?
And how big is the broker, right? How much do I need to scale up?
Exactly.
Right?
Like what happens when it fails, and so on and so on.
Right. And where do I put it? Because
exactly.
That introduces latency, creates scalability problem. Yeah. And with DDS, that it's essentially peer-to-peer. And, complex system cannot be either one or the other. The life is more complicated. That's why you need something that doesn't imposes restriction on you. Gives you abstraction, but unconstrained abstraction that you can, in a way, morph into what is best fitting your system. Yeah. But with this infrastructure, the question is, how do I manage it?
Yes, sounds complex.
Exactly, because now I need to teleoperate or monitor my robots. I'm sending robots in a globalized market everywhere. How on earth am I going to deploy, manage, secure this infrastructure? It's a lot of work, isn't it? But
that's why we are here, right?
But we came to the rescue, right?
Of course.
And that's what the Zetta platform does.
Indeed.
Right? And that's what we're going to see. So with the Zetta platform, you can deploy, manage, and monitor at internet scale.
Your Zeno routers, you can deploy you can configure all your clients, you can configure all your bridges if you need that, but not only at internet. What if I have an infrastructure on premise that I want to leverage through the cloud? You could do that.
And again, you raise an important point. Once I've deployed and secured my infrastructure, how do I generate the credential for my application?
Exactly. So the platform comes there for exactly. That. It automatically generates TLS certificates, MTLS certificates, and everything that is needed to configure ACL for your data.
And then we've talked a lot about robotics and about ROS, but now I have robots deployed. I need to debug something. I would like to see the ROS graph.
But you can.
Oh, right. You can, and we will see that live.
We'll see that live, indeed.
And this is the general trend, right? We have explained in the past how Zeno, when it was designed no, as a protocol, but well beyond the protocol. Because, like anything in life, things evolve, right? And nothing lives in isolation. So it's very important to be able, like for human, to talk as many languages as you can.
Yes.
And so when we designed Zeno, we made it possible for Zeno to easily plug multiple protocols. And so today we can talk DDS, we can talk with MQTT. You can integrate other protocols quite easily. And what we do in the past, as we will see, is that for many of these protocols, especially for the most relevant, or the technology to which we bring connectivity, like ROS2, then we integrate also the monitoring part, which is quite powerful. Okay, so how do we compare to the other stack? So today, Zeno as a technology and Zetta as a platform is the only stack that can go microcontroller up to the cloud, one protocol. Yesterday, I was giving a full-day seminar, and it was interesting because there were some people say, "Oh, I've been using MQTT SN, the sensor network version, and MQTT." And my point was, sure, but those are two different protocols.
Yeah, then you need to put a broker in between or something that converts.
Exactly. So. And Zeno is one protocol, always the same protocol, whether it's running on ESP32
or on the cloud.
Exactly, on a high-end processor. So the only platform that can provision in that continuum and the protocol that can do that.
Yeah.
And I hope people appreciate that the fact that the protocol can run in that continuum is what makes us also possible to so fluidly
connect everything.
Exactly. Energy efficient. So we have written rivers of articles on this matter, but energy efficiency really boils down to three aspects. There is computational efficiency, and you see that in performance evaluation. So on a given CPU, we have higher throughput typically than anybody else, which means we use the network and the CPU very efficiently. But then you have wire efficiency, which is how much overhead the protocol adds. And there, it's very hard to beat Zeno. You can configure Zeno to have a few bytes of wire overhead. Yep. And then there is the topological or the routing efficiency, okay? And I'll give you an extreme example. Today, we are controlling with our mobile smart thermostat through a cloud.
Yes,
right?
That usually is in another country.
Thousands of kilometers away.
Exactly. So your data goes.
I want to lower the temperature, right?
Yeah, you're wasting so much energy.
And I'm burning half a forest.
Okay? Probably, yes.
Yeah. And not because of the green data center, but because of the telco equipment.
Well, but also because of all the data that had to go through.
Exactly. And that's just because of topological limitation.
Yeah.
Because we use things like HTTP, that is point-to-point, or MQTT, and cannot do a peer-to-peer communication. So all of that has to stop in a way, and we give the opportunity to make things, to improve this. And energy utilization is actually quite important, and communication has the lion's share in energy sharing, right? Then PaaS, well, you have PaaS offering for obviously multiple technological stack, and now also for Zeno. High performance, we consistently rank very high, if not the top. Cloud native, but more importantly, and again, those that know me know that I really dislike the term edge, because for me, edge computing is like an oxymoron. It's not about the edge, it's about removing the edge, right? Because what is the right boundary?
Everyone comes with its own edge.
Exactly.
There is no one solution fits them all for edge.
Exactly.
Telco guy is one edge, the industrial guy is another edge, and so on and so on.
So the reality is that there is no edge, and it's a continuum, and that's what we address.
Indeed.
Okay. But again, we put edge because at least people understand, and then we can explain our perspective. Good. Shall we, Zetta?
Yeah, let's go.
Let's do it.
Okay,
so where do we want to start? From the
let's
beginning,
start,
right?
of course, from the beginning.
Okay.
So I will need a
I'll give
browser
you,
first thing.
Hold on a second. And we'll be using both laptop. Be careful. Can you hold on? There is something getting stuck.
Yeah, so I will
We
not
didn't notice that because we moved a little bit the table over. Here we go. You can pull it now.
Okay. So let me go to the pass.
I probably want to go with Safari. I'm not sure if the credentials.
Okay. Then let's go with Safari. So first thing first, I need the finger from Angelo. Well, apparently not. I need another finger from Angelo.
Yeah, that should be it. No? Did you guys change?
No, we didn't change. Okay, click there. Use pass.
Okay.
No, okay.
Should you join?
Try this one, or in most case, I join with the...
Yeah, I think most case, I think you join on your side. No? Oh, what's going on?
Okay. I'll join. Tell me how to join.
Stop. Yes, let me give you the link. That was the only things we didn't try before. Yeah.
So again, it's live, so things happen.
Okay, but that's something quite easy. Email.
Okay.
Okay. C'è signal sul tuo computer? No, okay. Okay, so you should get the invite anytime soon.
Just for the time for the email to arrive.
Yeah.
Eventually.
And look, actually, I'm now in, so you can also get it here. Got it?
Eventually, yes. Okay, that was faster.
Okay, perfect. Yes, great.
Okay, so
you should be in anytime soon.
Allow.
And now, well, actually, the advantage is that now we'll be able to show both of our screens.
Yes.
So we'll do.
Okay. Oh. Sorry. I should share my screen, right? The screen. Later. You can see my screen? No.
Not yet.
The link, well, history, restore previous session. It's easy enough. Allow, share screen, enter screen, allow.
Okay, that's coming up. Great. Okay, here we are.
Well, let's start from the beginning, but not the beginning. So I'm already connected to the platform. In this case, as you can see on the left side, I have the list of projects there. And this list of projects, I could see like ROS thing, Zeno thing, routers running on the cloud, routers on premises, and so on and so on. And in the middle of the page, I have a list of all the projects. A project is a Zeno deployment that is running across the cloud to thing continuum. So let's imagine I'm a robotic company and I want to create a Zeno deployment. So what I will do, I will first click on create project. I will give a name to my project. So it's my amazing robot project. And there I could give a description if I want to, can select the Zeno version in this case, just the latest version is available, or I can select a specific subdomain name for my projects in case I want my project to be like easy to configure. And of course, I can decide to provide my own TLS certificates if I already have a certification authority, or I could let Zetta to build them, to provide them automatically. So if I have them, I could just add there my certificate authority. Otherwise, I could just leave as default and then click next. On clicking next, I could select where I want to deploy. So in this case, we are seeing, okay, I have a region where there are no region, where I have a provider where there are no region active. That's clear. We'll see later why. But let's say I want to deploy first on AWS. I could decide the name of my router. So in this case, it's a router in Germany. Let's call it Germany, because I lack fantasy. And I could decide, of course, where to deploy. So those are the AWS region that we support nowadays. And I could decide also the size. The size has an impact on the bandwidth and on the amount of clients and peers and other routers you can connect to your infrastructure. I can also decide to have some advanced configuration. In this case, this advanced configuration is more about downsampling. So let's imagine I want this router to downsample all the LiDAR data coming in. I could just configure it by using the key expression and the configuration.
And in terms of use case, this would make a lot of sense if you were deploying boundaries routers on premises.
Exactly.
Right?
We'll see that later.
Exactly.
Indeed.
Yeah.
So you can also configure it on the cloud if you need it. Let's imagine you have some downsampling already happening on the robot side, but you'd want further downsample when going to the cloud. You can still do it.
Or between regions.
Or between regions. There are multiple use cases, different reasons to do that. Then what I could do, I could click next. Let's say, okay, so far I just configured one router, but let's say my company is very successful. I have deployments of routers all over the world. So I need to add more routers. In this case, again, let's select AWS and let's do a router in Tokyo. So let's call it Japan. And again, same size because maybe I don't have that much bandwidth going out. Okay, click next. And let's configure just another router. Let's go really all over the world. So let's go to the US. In this case, let's go to California. Again, I'll click next. There I have a summary of the router that I'm going to deploy. So if I want, I can search them. If I want just to see just one of them, or I can just click on them if I want to re-edit them, like change the size or change the region. Let's click next. Now I have to select how to configure how to connect my routers. So what I could do, I could just configure them in a click topology, which means everyone is connected to everyone. I will select the different routers on the to, I will select add, and then I will have my topology. So this is the actual topology that is going to be deployed by the Zetta platform. In this case, we'll see that the router in Germany is connected to both Japan and California, California to both Japan and Germany, and Japan to both California and Germany, which means that everyone is able to talk with everyone. Let's click next. There I could configure my storage. So I think you already know because we talk a lot in Zen about this possibility to have storages, so to integrate data at rest. And the idea there is to have some storages on the cloud. So let's imagine you want to store some data being published in an S3 storage. Then you could just add the storage, select the kind of storage you want on the cloud. In this case, either memory, which is kind of more of a volatile storage, or S3/mini.io. And there you can configure your S3 storage. So you could give a name to it. You can select which key expression will be stored in this storage and in which router to apply this configuration. Of course, as this is an S3 storage, you need to provide information like the bucket, a few parameters like if you need to reuse the bucket if the bucket is already there, or if you want the bucket to be only read-only because maybe you want us to get data out of it. You don't want to store data on it. And then, of course, secret key and secret key, access key and secret key in order to access to it. What else we could configure? We can also configure connectors. So we say with Zeno it's very easy to plug different technology. Let's imagine you are in a brownfield system, so you cannot afford to redeploy all your application, but you are already using, I don't know, DDS or MQTT. So what you could do, you could just replace your MQTT broker or your DDS thing with something with Zeno. And this, by doing this, means that, for instance, from the cloud, you could add an MQTT connector and then point your MQTT application to this Zeno router. In this way, you will be able to still talk MQTT with your application without needing to recompile them, but you will take advantage of Zeno, and your communication can go through the Zetta platform. Again, you can configure the configuration for the MQTT connector, like selecting a scope, which is a prefix that is going to be added to any key expression coming from MQTT, and also allow and deny, which is a way to avoid some topics to get in or get out via MQTT.
And by the way, the interesting thing is that when you activate MQTT connectors on Zeno routers, we would still route data between MQTT brokers.
Yeah, you can still do that.
So if you have MQTT application today and you want to get rid of the centralized broker, would be good enough to switch to Zen infrastructure, activate the plugins, and all of a sudden you can decentralized or distribute the MQTT broker without changing a line of code in your existing application, exactly. Which is quite important.
So, but let's say I'm happy with my deployment. There I have another summary showing also me actually the regions. We see both as a graph or as a list. When seeing the list, I could see if I configure storages and connector in the different routers. But without further ado, let's deploy it. So when clicking on deployment, the platform is going to generate all the certificates. It's going to talk in this case with the AWS, and it's going to deploy all the machines where the Zeno router are going to run.
Registering names.
Registering DNS names and so on and so on. So it's actually configuring all the projects in order to be ready to use. Usually this takes a few minutes. And while it deploys, actually, we could see an already running project.
Mm-hmm.
So let's take this project, the product we're using to development. In this case, you can see that I have one router on the cloud, and I have a few things connected to it. But what are those things? Actually, you can see we have 2 peers connected, and those 2 peers are actually running locally. And one of those 2 peers is providing connectivity to the other one, to the cloud. So in this case, this peer, which is B072, which we know is one of the robots that we have in the office, is providing connectivity to this other peer to the cloud.
Yeah.
Which means that this peer actually is not configured to be connected to the cloud. And just by discovering this other peer, then all of a sudden is able to communicate via the cloud.
Yeah, and this is something else that, sometimes is not full. People don't realize it immediately, but you have a swarm of robots.
Yeah.
If you are in a rural area or in a disaster recovery situation, it's not easy to give internet access to everyone. Indeed. So all of a sudden, you can mesh up your robot with a local ad hoc network, and then as far as you have anything
that can connect,
you can leverage that connection to communicate, with the operational center, exactly. Or whatever it is. Yeah.
But then you need to communicate.
Exactly. So that's essentially just the ability of Zeno to run on mesh networks. Yeah.
Indeed. So that's actually what is happening in this case. We have a Raspberry Pi sitting there, more or less, in which we have Zeno running, and this is discovering the robot through multicast scouting, and then the robot is connected to the cloud.
Yeah.
And as we can see, we have different colors for the different links because they mean different stuff. So in this case, we see this orange-like link is a TCP link. So it's an unsecured link because we configured the robot to have a TCP listener. But when going to the cloud, this link is both quick and TLS. So first is redundant because it's 2 different links, and quick is actually over UDP. And I would always come with MTLS authentication. And then we have a second link, which is the TCP based, and is a mutual TLS authenticated link, which means that to this router on the cloud, only clients that are configured with the proper certificates can connect. It's a way to provide boundary security to your infrastructure, which means if someone else gets the address of this Zeno router, cannot connect to it. As simple as that. Then we have also something running, in this case, on my laptop. We have a router with the name Gabriele, like me, and I have a publisher and subscriber, and all of them are running on my laptop. But do you want to start something on your laptop, Angelo?
Let's do it. And maybe we can even try to show both screens. Let's see. Shall we?
Yeah, let's try.
Yeah, let's try that. If it doesn't get too small, I think in this combination...
You need to select.
I need to select here. This one, up, yes. 1, and 2. Great.
which means that with this single file, you can take it, copy in different machines, and those machines will be able to connect without needing to bother on configuring paths for the certificates and so on and so on. Everything comes in line in a single file, and I think it's quite neat. So Angelo started his things on his machine. As we can see, now there is a new router running on Angelo.
You know what?
Laptop.
I'm going to start a subscriber now.
So I'll start a subscriber, and is receiving the data. You cannot see Angelo receiving the data.
But I will start. You're seeing my subscriber on the tool.
We can see a subscriber there. Yeah, is
and
appearing.
I'll start a publisher too.
Start a publisher.
So if you.
But okay, we have things running there. But how we ensure that we are receiving the data? Well, actually, I already have.
No audio. Okay. Apparently, they tell us that we have an issue with audio. Do you mind double checking? Because here I have nothing muted, and I can see that the audio is being picked up here. Okay. So just a moment, because they told us apparently there is no audio, but I don't see any problem here on our side. Okay. Please, someone that is online, can you let us know if you're having audio issue? Because locally we see everything working. I see good signal on the audio. Okay. Would be good to know if the audio is good now or not. Is good? Okay, so it was probably a temporary glitch. Okay, good. Thank you for confirming. Okay. So we can continue, yeah.
So I hope you didn't lose that much, but what Angelo deployed a router and a publisher in his laptop that actually we can see there from the platform.
Exactly.
So we have subscribe. Okay, both have the same name, so you may misconfigure one of them, but it's fine. It's completely fine. Use the same configuration file.
Hold on, but I'll change it.
Yes.
So that's the subscriber. So that's good. So I need to change the configuration on the publisher. Yes. So that's just a moment.
So the deploy takes few seconds in order to update.
Here we go.
So here we see again the subscriber that has been started, and in a few seconds we should see also the publisher. Let's wait. Usually it's around 30 seconds, like the refresh time for the interface. And it's there.
And there it is. Yeah.
So you see we have a couple of publisher and subscriber on different machines. And if I go to my VS Code, I have a terminal in which I'm receiving the data. And as you can see, I'm receiving demo Gabriele and the demo Angelo, which means I'm receiving data from both. And in this case, the data is actually going through the Angelo publisher, up to Angelo router, up to the cloud, to my router, and then to my subscriber.
Yeah. Do you have any storages on this router?
Yes, we have storages actually on both routers. We have storages that actually, if I'm not mistaken, we could see from there. Yeah, you see, I have a storage that is demo Gabriele, and in Angelo, I have a storage that is demo Angelo. So this is the tail page from the router in which you could see information from the router, like its ID, where it's running, what are its addresses, and what are the Zeno sessions that this router is having, and of course also storages and connector if there are. In this case, Angelo router has a DDS connector. So what we could see, we say there is a storage on demo Angelo.
How about we query?
Yeah, let's query it. And you know what? Let's query it through the web interface, from the REST API. So in this case, the router are configured with the REST interface that is always open.
There we go.
And we can see that we have both the data coming from Angelo laptop, can make it bigger, and the data coming from my laptop.
But do another query, so you will see that the sequence number increases.
Yes.
Yeah,
so
there we go. Yeah.
So what if you stop your router?
Yeah, and that's the interesting things, right? Because this data, part of
this data is actually
stored on your side.
Exactly.
Part of the data is stored. And you know what? Before we do that, I'm gonna start another publisher with a slightly different.
Okay.
Okay, let me do that.
This was not tested, so hopefully everything works.
Of course. It will. So let's do that. Just give me one moment. I need to source the virtual environment.
In the meanwhile, I'll present also other features from the platform. So as we see, we have some details information about the router, but what if I want to see how much data is going through one of my router? I have metrics per router, or the metrics for the whole project. So there I could see, for instance, how much transport data, how much data is being sent on the network for this router, how much transport messages, and so on and so on. So I could get information about the usage of my router. And I can also see them per project, which means, per project. And there I could easily see, let's say, the last hour. So there I have information on the total bytes being sent on the last hour with a pace of 1 minute. But I could also decide to see them live data.
Yeah.
And I can see them in a cumulative manner or per second, which can give me as an insight of how many bytes per second are we sending. So in this case, we are around 33 bytes per second.
And you know what? I'll do even more interesting things. Yes. What I will do,
so I will publishing. So should have. Yes, I have another data there.
Correct. So what I will do now is actually to publish also something on your key.
On my key, okay.
Yes. And then we see what happens when we disconnect. Okay. So we'll see, right? Okay, so let me do that.
So meanwhile, we could also get information about all the key expression for queryable subscribe declared in Zeno. So in this case, if you go for demo, we could see all the key expressions that were defined in this project. So all the subscriber and queryable that are connected to this project. We could see, for example, for demo, let's say Gabriele, we could see where are those things declared. So there are actually queryable and subscribe. So there is a subscriber and a queryable declared on this router, which I say so you can do a query. Router.
Let's see what you get.
So let's do a query, and now this was written by Angelo.
Yeah.
So if we update, we see that sequence number change.
Yeah.
And what happens now if you disconnect your router?
Let me stop my router.
Is that one? Oh, okay.
Yeah. I do it
you
from
stop
the
that one.
Yes,
okay, you saw it from Docker.
Yeah.
So if you go back there, we'll see, so many things connected.
Of course, because now the 1 zillion of applications.
1 zillion applications. So the router is, I think, disconnected. Of course, it takes.
But to Docker, it takes some time to.
Some time to destroy. But then if you go there and we do, I want to do a query again. Oh, I don't have any more Angelo data, which means that Angelo data was stored in Angelo laptop.
Correct.
And was only fetched because I asked for it. So the data was not by default being pushed.
And so do refresh, because there is something interesting, right? So if you look the number.
So this one is not updating anymore.
Exactly, because it was being written by something connected to my router, but for a key that was managed by your storage.
Indeed.
So it got stored there, and the data remains for your query, but whatever was in my storage isn't.
Indeed.
So that's quite nice and shows the distribution of storage, which I would also recall are automatically aligned if you enable that.
If you enable the alignment, yes, they're automatically aligned. So what else we could see on the platform? Well, we have ROS, we said.
Yeah, sure.
So as I say, I have a robot connected to this project, and actually, it's a robot that, if we want, we can actually control. So this is the robot is sitting there in the office. And in this case, I have this web page that is connected to the robot to the router on the cloud, and I could drive the robot. And as you can see, the LiDAR is updating. So just to keep in mind.
Sure. Let me point to the robot. Keep driving. Hold on a second.
You see. Oops.
Hold on, because what is it? I have to do like this.
Okay.
Okay, drive.
So in this case, this robot is connected to the platform. Okay, let's imagine all of a sudden it stops working. I try to drive, but I cannot drive. I will say, okay, but I want to see maybe the ROS graph, because maybe something is wrong there. I could click there. I could say, okay, in this case, the robot is connected to domain 0. Bam, I have my ROS graph. And with the ROS graph, I can have either the ROS graph per se, or I could see just by the topic names if I want to. And which means I could see the topic name, what are the publisher, the subscriber to that topic name. So I could see the nodes that are publishing, and in this case, this is publishing, this is subscribing to this node. But I could also, if I go back to the graph, let's imagine I see that I think that motion control is not working for some reason. What I could do, I could click there, and I could see the graph from the point of view of the motion control, which, again, I could see it as a graph, or if I want, I could see that as a list. And I could see also subscribers. So in this case, I see motion control is publishing to those topics, and those are the nodes that are supposed to receive the data. Same thing from the subscriber point of view. And I could see also if there are clients on which service name, there are service action, and what are the service server for this. So what else we could show on the platform? Well, so let's imagine, so let's go back to our previous project.
Yeah, we didn't show to do subscription or query because you can do that, right?
You could do that.
Yeah.
But let's imagine I've started my project and say I'm developing, so I don't want to pay it for it running without using it. What I should do? I should delete it? No, you can just stop it. And by stopping means that the Zetta platform will tear down all the resources. So you're not going to pay for the things because they are not running, but you don't need to reconfigure them when you restart it. Of course, this means that all your certificates will be kept and be stored, so your clients will be able to connect again once you start the project again.
Yeah.
So we have bridged Zeno communication. We have connected a ROS robot to the cloud. What about DDS?
Yes, and are we going to show also to provision?
Yeah, I want to keep the cherry at
okay. So let's keep it quiet. Okay, cool. Okay, great.
So actually, I have another project in this case, which is called DDS on the cloud, which by the name says is going to connect something DDS on the cloud. But I first need to stop a few things from running. And actually, this is also a way to show you guys the tooling, that Zetta C2. What did I mean to show? To open that new window. So first thing, I will start a DDS application. In this case, I have a nice shapes application. The scale, Cyclone, wrong. DDS shapes. Build bin.
It is Cyclone demo.
It's just there. Okay. So I have an shapes application. This application is a usual DDS application. Let's imagine I want to subscribe.
Yeah.
So far, I'm not connected to anything. So I don't have any DDS application running on the same network, no publisher, and I'm not receiving nothing. I want to connect this to the cloud. So what I could do? Actually, let's use it. Let's use the tool to do that. I could start the tooling. So the Zetta C2. Zetta C2 is our tool, which is kind of a portable version of the PAS, we could say. And this allows you also to get the same amount of information you get from the PAS, but as we could see, this also provides an handy way to have a bridge.
Yeah.
So let's say I want to use an existing configuration, and this is the configuration I want to use. So this is a configuration that I generate from the platform to already have the DS bridge inside. So there is connected. So it discovered something.
Yeah.
And as you can say, it discovered a subscriber, actually a participant with the reader on the topic circle. Let's go back to the PAS. Actually, as we can see on the PAS, we have a peer application, a client application, sorry, which is my tool, that has discovered Cyclone DDS demo shapes, which is the name of the process. And if we go on the DDS page on the platform, we actually see the exactly same information we have seen on the tool.
Which is great.
But this is on the cloud.
Exactly.
Which means everyone else could see it. Everyone that is connected to the same project could see it. So it's a way that you can use to inspect your running DDS system from remote, which I think is quite powerful.
Exactly. Your client, you have a running DDS system, your client has a bug.
Yeah, you can just...
You can debug it remotely.
Right? And actually, you can debug remotely by means you can actually check...
and it's cool because you just need to have our tool. You have your tool as a developer, right?
Yes,
you start the tool, connect to the PAS of your customer, boom, they can do a remote debugging, right?
And actually, you could see the same thing. So let's imagine you are connected to some support, and the guy from support is telling you, actually, you guys can see the same thing that the person on the field can see with the tool on the cloud, which also helps a lot on debugging.
Yeah. So how do you want me to connect mine? With the router or with the tool?
You could do with the router first.
Okay.
No. Yes.
This one. Yeah. So
this one need to connect with the tool because the router is in Docker, and that's Docker
so
limitation.
With the tool. In any case, I'll do this way, and that was the configuration.
Yes.
Yeah, that's it.
We have a router running?
Okay, great. Okay. Yeah, I already discovered you.
Okay, that's good. So if we go back there, we see that now there is another tool running, which is Angelo tool in this case. See, AC tool is Angelo Corsaro.
Exactly. And I'm going to start a shape too.
Let's start iShapes.
Let me do that.
And let me bring my shapes there.
And I'm going to publish.
Yes. Oh,
woohoo, it's moving.
We immediately received the data.
Yes.
And we didn't add the time for the web page to update and saying that it discovered something that we already see.
Obviously, I already see it because
it's localhost, so it's faster. And now let's see there.
Yeah.
So now if you go to the DDS, we will see that actually in the topic circle, we have 2 participants. We could see where they are running. So we see there are 2 different hosts. And we could inspect.
I'm going to subscribe to Square.
We are going to subscribe to Square. You want me to publish something that mismatch?
No, first let's do you publishing and then red, whatever color.
Green.
Okay.
Let's publish it.
Perfect. And look, let me show my screen because I think it's good to see on both sides, so we can quickly. Yeah. So this is the tool.
This is the tool.
Okay, and this is the Shapes application, right?
Yep.
So let me go back to your screen. Let's enable your screen sharing, which is this one.
So as we can see now, we have 2 topics on circle and square, and we have 2 participants that are the same actually as before. And for each participant, we could see that this has a reader and on square and a writer on circle. And this is the
you know what? I'm going to start another Shapes application, so we'll see another participant pop out.
Okay.
And I'll do 2 subscriber here. In fact, I'll do subscriber for everything.
So no matter what we publish. So we already seen it. This is there, and we see that there are 3 readers for that.
Yeah.
What about a mismatch?
Yeah, actually, let me do something. I closed it now.
You closed it, yes. Wrong button.
No. I wanted to close it because if you want to, because I didn't want then, as I created 3 subscriber for how we're going to make the mismatch, one would have matched, right? So,
okay.
So I'm going to subscribe to triangle with exclusive ownership.
So I think just go to a triangle.
Hold on. Let me up. Okay, so you let me publish back the circle. Let me subscribe to the square because I closed also this one. Good. And then I want to change. I will do exclusive ownership for a triangle.
For a triangle, okay.
Showing the tool first. Once we get the.
So, okay. So let me publish my triangle. So I'm publishing my triangle. I miss this. Okay. Did share exclusive? No. Okay.
Okay, we'll do this in the other configuration.
Okay, well, I can see a mismatch, but I can imagine why you're seeing that. So we'll see that now we have triangle, writer, and actually there is an X. Well, what does it mean? Let's inspect that. And we could see all the QS in detail, and we have a cross, which something is not working on, might not work. And as you can see, you say that the ownership of this writer is shared, and there is actually a reader that was with kind exclusive.
Yeah.
So if for some reason you are not receiving the data, this will tell you, look, there will be a problem. Maybe it's done on purpose, but there may be a problem.
Yeah.
So you want to see actually what is happening with the QSs. Yeah. The same thing, of course, you could see from the tool.
And by the way, I mean, just to put this in context, can you show back the DDS application?
My DDS application.
Yeah.
With this.
Yeah. So this is incredibly smooth. It's trivial to configure.
Yeah.
And if you compare this to what some of the other vendors have tried to put together with things that are not even close to what we were doing 10 years ago. I mean, look how easy it is by combining Zeno and our DDS, right, Cyclone, to have internet communication. And you can go beyond, you can do monitoring, right?
Yep.
This is the level of integration that we have that goes well beyond what any other DDS vendor has. And this is the vision that we have, right? Zeno is this protocol that allows us to get anywhere and to which it's easy to connect anything else.
Indeed.
And that's what changes the game. Okay, and then you also see the performance.
Indeed. I mean, all of this is running. You have to remember, it's going through the cloud.
Show how many hoops and hops.
So it's going from my Cyclone to
a router
to my client, which is to my tool, which actually has a client. So it's writing the DDS data to Zeno, to a router in Germany, so in AWS, in this case in AWS, to Angelo router, which is in his laptop, to his cyclone A shape.
Right, and vice versa, because we are crisscrossing with readers and writers.
And doing that, we can also see...
Add some history, so because that will also be interesting.
Subscribe with history?
Yeah, subscribe to Square, and I'll publish Square with history. Okay, let's do a big history, because then you will see how smooth it is.
Well, big, I will... Let's
just slide it. 10. Yeah, even you can exaggerate.
No, I will put 10. You said Square.
Yeah.
Okay. Apps. Is already correct? Yes. Subscribe.
Good.
So I can see my history.
Of course. And now I'm going to start my publication.
Yes, I can see the history there. And it's going very smooth. And it's a pity we cannot share both screens at the same time. But I could see that there is...
we can show with the camera, actually.
We can show with the camera.
Let me do... Let's see if I completely mess this one up. Okay. But then it will be... Well, the video won't be... I don't know what the hell we are showing.
But I mean, you can see that there are... I mean, there is very little
what we are showing, but yes. Hopefully you saw something.
I mean, this is also this is going through Wi-Fi while we are sharing, we are streaming. So we are putting the button on the network.
Exactly.
And we could inspect everything that is happening in the DDS system.
Yeah. You should put a bigger history. But in any case, go back to the history, because whenever there is jitter, what happens is that you see the history getting stuck and then resuming, and you see how smooth it is. This is why I put a history of 50. Because then people try to do it something else. You see how smooth?
Yes. Okay.
That's the proof of the pudding. Okay. Okay. Cool.
So, we are almost already at the time, but I wanted to show something before showing things locally. I want to show one thing. So
I'll shut down my router meanwhile.
Yes. Okay.
As you want.
Yeah. I can also shut. Let me shut down a few things there. This one and the tool, because I don't want it to run. So we say that what if you have your own infrastructure?
Indeed.
So
I have a factory or in our office.
Or in our office. So there are two ways actually to deploy. Let's say the automated way, which is what I'm going to show, and the not automated way, that is the one by going on use my project. Sorry, wrong, misclick. Use my project and create a local router. Which is
what we've been using.
What we're using all the time. Exactly. So this is, let's imagine you want to a router on your machine. Most probably you're going to use that. So again, you can give a name, decide where to connect, configure ACL and downsampling. In this case, we have ACL because this is an edge router. So where we're supposed actually to do ACL. And then you can...
And again, it's important to underline, ACL is not just for security. Perhaps you don't want some data to get out because it's irrelevant.
Yes,
right?
Yeah, exactly.
So there are multiple reasons why you want to do ACL.
Yeah. Exactly. So let's imagine you have a topic on your robot that you don't want to go out because it's just a waste of bandwidth. You can just deny it with ACL.
Exactly.
Doesn't need to be only for access control in the sense of security.
And the issue is that sometimes, right, that avoids bugs in your system that can be pretty disruptive.
Yeah.
And I recall, so in air traffic control, for instance, you have to guarantee for safety that there are certain topics that certain application cannot just subscribe.
Okay.
Because that would disrupt the network.
Okay. Because too much data.
Exactly. Or you don't want certain data, to avoid disrupting data, to go out of a given boundary. Yeah. That's how you would use it.
Exactly. You can just do that and it's fine.
Yeah.
So, but let's back to configure your routers. So in this case, you can give a name, you can configure the router as we have seen. So add storage if we want. We have a bigger selection of storage for on-premises routers. And again, connectors. Again, bigger selection because like DDS and ROS2 make sense only on premises. And then, but what if you actually want to deploy something on a kind of cloud infrastructure? Let's imagine you have a Kubernetes deployment in your factory. Well, you could add your region, and your provider, and then your region as part of your organization in the Zetta platform. So you can go to the user menu, organization, manage providers, and there you can add providers. So let's imagine I want to add one and say is Linode because I have a deployment on Linode. This will add this provider, and then I could add region to that. And in order to add a region, I can create a region. I will give him a name. Let's call it Paris 1. Give him a code. And I can actually, if I want, I can give him an image, like an icon to see it. Mm-hmm. Let's say I don't want to do it further. I needed to put an image. Right, let's go for one that is already created. So in this case, we have a Zetta scale provider, and I have a location that is Paris office, the icon. In this case was the French
flag,
and the status is up. Of course, when creating, the status can be up or down, depending, because you need to start something.
Yeah.
And actually, when you create it, then you need to download something in order to run this region. So when clicking on download, you will have a zip file that actually I already have downloaded. So where it is, downloads. Let me open this with VS Code. And what should actually get? You get a README, which tells you how to run it. Actually, what you get an Helm chart, you get a values file for an Helm chart that allows with one single command to deploy this region on your cloud, on your Kubernetes cluster. So we already did that for the cluster that we have in our office. So you see, okay, you can. This is what contains. This is how to run it. This is the result you should get once you deploy, and those are all the prerequisites or the requisites that the way we tested it and the way we know it works and what it actually creates on your Kubernetes cluster, and also some troubleshooting tips if you need them. So we have this region up. Let's actually deploy a router. That should be faster than deploying on the cloud because it will be on our premises. So again, let's call it local deployment. Click next. So let's select Zetta scale. As you can see, so that's why we were getting the error there, because I was using a provider for which had no region up. But if I select AWS, for which I have region up, or Zetta scale, I could deploy there. So I can see Paris office. In this case, I have just configured this size for the router. Could click next. Okay, again, I don't want to add any storage, any connectors. For them, I just want to deploy a simple router. I can click on create projects. This again is going to generate all the certificate, and using few Xenomagic in this case, we could say that is going to deploy the router on premises. So in this case, in a Kubernetes cluster that is running in our office, and that was very fast. As we can see, the router is already up.
Yeah.
And of course, if we want from this router, we could configure something to connect to him. So I can configure a client application to connect to this router. And again, similar as we have seen before, I will get a zip file with already the IP address and the things configured to this deployment. Few things that are worth mentioning with this case of deploying, that it can be any Kubernetes cluster, which means also on premises. On premises means no public IPs. So usually when the Zetta platform deploy routers, tries to register a domain name to that router so that it's easier for the user to connect to it. But in the case the router is on premises, we cannot do that. So that's why when configuring the client, actually we put the private address of the router. That is the one that was returned by Kubernetes, which means that if you are using some load balancing or some other technologies to get your Kubernetes router exposed on your local network, this is enough to connect to it.
Good.
Okay. Want to show anything else? Well, of course, once you are done, you could, again, just delete your project if you really don't need it. I'll just show it.
Okay, cool. We are not done.
We are not done.
So let's do, we are a couple of minutes over, but I think it's worth.
Okay, so I want to do something local, right?
Yeah.
Okay, so let me actually disconnect from the platform because I don't want to use it. And okay, let me just start something locally. So I have in my VS Code, my friendly VS Code, I will start some routers. And actually, I will connect to this router via the Zetta C2. So I'm connected in this case to a local router in which I have just a publisher because I did misspell the.
I'm gonna start my local router too.
Yes.
Shall I?
Yeah. So I've started also a subscriber, and so far we can see that I have just my and we can see more things appearing. So Angelo just started the router.
Yeah.
We could see it there. And if Angelo starts also the publisher.
I started the publisher.
Okay. It's not
Can
yet
you see it in
up.
your application?
Yeah, it's arriving. Okay.
Yeah. And the subscriber. I see your publication.
Yes.
So, there we go.
There we go. So that's very similar to what I've seen to the cloud. But in this case, I want to pressure that everything is local. Yeah. So it's my laptop connected to Angelo laptop, and we can still get all this kind of information. So we could see the topology. We could see also the data. So what if I want to do the periodic get? Instead of going through the REST API, what if I want to do a get on the storages? I could do that.
Yeah.
But what if I want to see the data live? Okay, then I could add an entry to my dashboard. In this case, I want to actually subscribe to this data. I could click switch, and there actually we're receiving the data live from the subscriptions. This is very powerful, which means all of a sudden you can actually inspect your data that is going through. Of course, as we have seen, we say that the tool is kind of a portable version of the platform, which means that if you need to generate configuration, you could do that. So you can click on the generate configuration button, and there you have a very nice editor for everything that has to do with Zeno configuration, including, let's say, I want to connect to an existing router because I discovered it. I could just click there and I could connect to it without needing to go and fetch what are the IP address. But let's imagine, say, I want a secure deployment for my things locally because I want a secure deployment. So there I could select TLS. Let's imagine I want to list on localhost and port 7447. But now I need to generate certificates. Nope, because the tool is able to do that for you. So once you enable TLS, you have all the information to generate a certificate authority, and then generates all the certificates related to this
very,
certificate
very handy. Right?
And this means that we generate the file, we give it to you, so that then you can generate other configuration with this certificate authority. So click in there, we will generate based your TTL and your bits that you want, and we'll give you both the certificate and the key, so that then we can use for more deployments.
Yep.
And there, we can expect all the information about this Zeno system that is running. If there was some DDS information, we have already seen it before, we could see that.
And by the way, I believe you showed from the platform the fact that you can download the configuration for connecting for the
maybe
tool.
I didn't show that.
I'm not sure, right?
But let's show that. So let me disconnect from there and let me go back again to the platform.
Because it would be nice to show that.
So let's imagine you have both we can show also how to get the tool actually from the platform.
Yeah.
So let's imagine I want to connect to this project. And I want to use it to connect with the tool. So I can go on use my projects, click on the use my project button, and then decide to connect Zetta C2. There is going again to ask me where I want to connect. Is already giving me a name. And by clicking next, is going to generate me a package that is very similar to the one for the client and contains a configuration that I can use directly to connect to Zetta C2. So if now I download this, let me put this somewhere. Oops, I misspelled MKDIR. Zip it. Okay. There I see I have a configuration.json. Let's say I want to use this configuration. Go to downloads, I call it demo config.json, and open. And this is connected directly to the platform.
Yeah.
We are stressing the network a bit today, but it's connected automatically.
Cool.
So that means if I have a deployment on the cloud and I want to connect through a local tool, I could do that. And this means that actually I could use any other configuration that I'm generating through the platform with the Zetta tool, which means what if I want to have a tool that is also DDS bridge? Then I could just configure a DDS bridge on the cloud and use that configuration with the tool.
Okay, very good. So it's time to go, unfortunately but we'll do more in the future. So to summarize, right?
Yes.
So first of all, the Zetta platform is there.
Yep, everyone can use it. You can just register,
sign up, register, and enjoy it. It makes it super easy to deploy a Zen infrastructure.
Yep.
But it goes beyond that, right? Because all of a sudden, yes, Zetta infrastructure means deciding how things communicate, getting you global connectivity,
Indeed.
But also, as you saw, deciding where to store data, giving you access to other technology. We show DDS,
we show ROS.
ROS2, right? And the principle that we've always said, which is bring your own data center.
Indeed.
It is there.
Just add the icons, but then
the icons is very important.
It's very important
for aesthetics, exactly. Okay, Gabriele, it was a pleasure, like always.
Same.
Thank you. Looks very cool.
Yep. See you next time.
The tool is also super cool, right?
Indeed.
Yeah.
I mean, it provides you. I mean, let's say you have a completely air gap deployment. but you want the features from the platform,
even the monitoring, right?
Even the monitor, you can just get the tool,
and then you can connect to the platform, and that's kind of our principle. Doesn't matter where you are.
Yeah, it's important you can communicate.
Unconstrained.
Yes,
yes,
indeed.
great.
Okay,
thank you, Gabriele, and thank you, everyone.
Thank you.
Take care. See you later.